Alright, hello, testing. So today I'm gonna be showing how to how to download the bacteria project. So I've sent a link to the GitHub, and so essentially you just have to download as a zip, right? Just like that, and then we can extract it. So now you have this folder, right? And then next, you're gonna open your IDE of choice. So for me, it's VS Code. And you're going to navigate to the folder that you downloaded it in. So this folder, I'm gonna open it, and we're gonna open this folder. Okay. Don't open like the bacteria.py file. You have to open the folder itself. So this is important because some of the features only work when it's in a folder like this. So it's just a quick tour, or maybe I'll just give a quick preview of how it looks like. So here's how it looks like. Keep in mind to download all the libraries first. Then only then this will work. So we have a simulation screen on the left side and a like graph screen on the right side. And when we close at any time, you'll get an Excel file. So if we go back to the folder, you'll see an Excel file. And so this Excel file basically saves all of the simulation data as well as the parameter data. So you can imagine with this you can like build a machine learning pipeline to really go ham on the analysis. Alright, I'm just gonna delete this for now. So this is bacteria. This one, right? Okay. So just a quick tour. These are the libraries. These are so this piece of code right here basically just sets it plots the entire application screen somewhere like defined on your screen. Um, I this is mainly because I need to like we need to be able to see the top navigation bar like this part. That's what enables us to move it around because previously if it's like on top, like you can't move the screen down. So that's why that's why we added this. So this has all of the parameters which the user can edit as they wish. Keep in mind some of the comments here state how big or small and what happens if you go beyond certain limits. And this part here saves the Excel file that we saw just now. It just stores all the data. So over here are the Pygame screen elements. So the FPS, my computer is pretty good, so I can run it at like hundreds of FPS. Other computers might lag. I could potentially crash your computer. I think we do have defined some colors. So the tiles are just so this entire part just defines the Pygame. So for instance, if I just write now, um, so we can see how big each like block is, right? So if I change like for instance this part to 5, then we will have smaller tiles. So if we look a little bit more detailed, so see it's really small now, and the the tendrils look a little bit strange now. But yeah, that's what more or less what it does. Uh, and we also have the sunlight grid code. So the radius and the center we can shift it as and when we like. So for instance, this is 2, like 2 looks like this. So the radius, I think it sort of puts it halfway. And so, this how that's how it looks like for like radius divided by 2. So if we change it to let's say divided by 6, it will look really small. Yeah, it will look like a really small pocket of sunlight. And so no two bacteria can share the same cell, like they are not allowed to overlap. So this really like by making the sunlight area smaller, it will make them like really compete for this. And some of the traits such as like the tendrils, the tendrils allow them to like detect everything in their environment. So other bacteria and sunlight is what they mainly detect currently. So this sort of makes the tendrils trait really favorable to find essentially pockets of sunlight. So we could just change that back to 3, and we can also change where the sun is. So let's say I change this to 6, it will actually the center of the sun will actually move. So sort of like that. Okay, gonna undo that. We can also change the color of the sunlight if that's something important. So I could just change this to like another RGB value, and maybe so give it blue. Yeah, just make it blue. Yeah, that's it's just colors. So this is the giant bacteria class that defines all of the attributes and methods, and really just defines all their behaviors. However, one important one would be the live. So this live essentially encapsulates all of the methods into like one neat function, which will be called later. So if you can see here, depending on what happens, they would do what. So this is also where the random number generator lives, like because it's a little bit hard to program a brain for each bacteria. So instead, we just make them move about randomly. All right, so let's skip the whole class. This is what the graphs take, like the code is from here. So it's very memory consuming because essentially without, like, what's happening right now is that there is a hidden screen right now, and basically each time the screen pops up, this application will take in an image of this and then straight away delete it and just keep repeating it. So it kind of gives this illusion that this is like updating in real time when it's really just like a lot of um, graphs being plotted and deleted at the same time. Okay, so yeah, see it. You save the image and then immediately after you just delete it. So this is the main Pygame loop. So some familiar things like starting number of bacteria, and we are plotting them randomly across the map at the start. Then here we are kind of drawing the sun and the outline just for the users like visuals. So here is the live. So we encapsulate all of the methods, and then die. So die just checks whether things are dead, and when it's dead, it'll remove it from the bacteria list. So bacteria list is just a list, and it just contains all the objects. So the more bacteria on the screen, this list has a longer length. So the rest of the code is just updating that Excel sheet like component. So yeah, let's take a look one more time. So for example, if you're a user, and let's say I want to start off with okay, let me just change the tile size back to 10. So I could start off with, let's say I want to start off with let's say 40 bacterias, right? And then so I can just change any other parameter, but for now I'm not going to. So yeah, you would start off with 40. So it's crazy. So these tendrils, let me just start with something smaller. Let's just say 4. So these tendrils, as you can see, they kind of wiggle. So we want to make the bacteria look, less, random object and more alive. So the tendrils actually do change frames, like they flip back and forth. The white circle is intended to look like a heartbeat, again, just to make them look more alive. So sometimes you can see that, there's hungry and mating. So that's their mood states. It's random. And so the HP bar is also kind of shows their max HP. So uh, when it's yellow, it means they are kind of like in a normal state. And when it's green, means they are definitely in a mating mood. And so when they're hungry, they will attack others. When they're mating, they will try and find others to mate with. The tendrils allow them to detect other bacteria that's in that tendril cell, as well as sunlight. So if it comes into contact with like a sunlight cell, the sunlight cell is more than 0, and it'll go there. They will try to keep going to the highest point. So that's why they all kind of like coalesce here. When their HP is not in the red, they will actually run away from other bacteria if they are not in mating or hungry mood. So that's why this explains their like kind of like behavior. All right, and so when there's no mating happening, the average traits will kind of stay the same because it just takes the average. So when somebody mates the new bacteria, the traits actually change. The lifespan also decreases, like this average lifespan decreases whenever a new bacteria is spawned. Right. So that is about all there is to the code. So all of this, you can use it for analytics, and it's intended for the user to kind of make their own judgment, in the sense that, okay, they see that the population isn't moving much anymore. You can just close and then get all the simulation data. Or when they've seen enough, they want to just close it. Maybe they've seen exactly what the parameter does in a certain amount of time steps. If all the bacteria died, there is no more bacteria left, then this simulation will just close by itself, and then it will basically print out the champion bacteria and its traits. So let's say if I just do one bacteria, and then I say that the cost of living is, let's say, mm, say 100. So every second that they live, they will like lose 100 HP. So yeah, so he died really really quickly. So yeah, we can see that this is their DNA. So that bacteria just now had a tangible value of 3, absorption of 10, membrane of 4, synthesis of 0, 4, and 5. So yeah, and go back and check the simulation data. So you have to manually kind of save this on your own, and because each time you run a um new simulation run, you will actually create a new one. It will kind of like, sorry, you will override that one. So that is about it. I hope this was informative. Thank you for listening.